Hello friends, today's question. A cubical block of side L rests on a rough horizontal surface with coefficient of friction mu. A horizontal force F is applied on the block as shown. If the coefficient of friction is sufficiently high so that the block does not slide before toppling, the minimum force required to topple the block is. So this is our block. Force F is being applied at the top of the block, and L it's basically a cubical block, so L will be one of its side, and we are supposed to find out what will be the minimum force F required to topple the block. In this case, let us say that A is the point about which the block is supposed to topple, or edge. So we are going to have a frictional force F are acting on it, and there will be a mg acting downward, and there will be normal which will be at this point N. So it means for the block to topple, you can say for the block to topple, the applied force, in this case which is M, applied force F must create a moment about the edge of the block. About the edge of the block. And second, you can see this moment which is being generated, this moment must be sufficient to overcome the restraining force. The restraining force moment due to weight of the block, weight of the block, that is mg. So there will be two, you can say the torque will be generated by two forces. One will be the applied force F and another one will be the mg. So in order for the block to be toppled, so this applied force, the torque generated by the applied force, should be sufficiently large to overcome the restraining torque that is being generated by the mg force. We can say that the moment due to the force applied F, moment due to applied force F, let us call this as moment F, moment due to force, moment force, which will be equal to F multiplied by the perpendicular distance L. Okay. So we can say this is the line of action of the force. It is going to pivot about, topple about point A. So this will be the, you can say, the perpendicular distance between the applied force and A. Now in the second case, the moment due to weight of the block, moment due to weight of the block. So this is our mg, which is acting through the center of gravity or center of mass, and its height will be L by 2, and this distance will be also L by 2, and this is the point A about which it is supposed to topple. Therefore, we can write it as weight acts at center of gravity, which is at a height of L by 2 and a distance L by 2 from point A, which is at a height of L by 2 from the base, base means this line, and L by 2 from the toppling edge, which is A in this case. So therefore we can write that moment due to weight, you can say moment due to weight will be equal to mg, and the perpendicular distance is L by 2. So the condition for toppling, moment force should be greater than or equal to moment due to weight. We can say FL is greater than or equal to mg L by 2. L and L cancels out, so we get F is greater than or equal to mg by 2. Now in this case, we are supposed to find out the minimum force. So therefore we can say the minimum force F will be equal to mg by 2. So for this value of force, the block will topple, and the option C is the correct option. You can say option C is correct. So this completes the question. Thank you.